Hey, RISC-V enthusiasts! Today I'm going to show you how to control a NEOpixel LED strip using the MilkV Duo Linux core. If you've got a knack for combining hardware and software, stick around because this is going to be fun. Alright, first things first. Let's talk about hardware requirements. First we'll need a MilkV Duo, which is a compact high-performance dual-core, RISC-V board that runs both Linux and Arduino. Then grab your NEOpixel LED strip, a power supply, some jumper wires, and some type of level shifter. The Duo board can be either the 256 meg or the 64 meg version. Some sort of external power supply is necessary if you are going to light up more than a dozen or so LEDs, depending on how bright you make them. In my testing I used a 15-pixel strip and powered it directly from the 5 volts on the Duo board. That said, I highly recommend a breadboard power supply at a minimum to avoid damaging your Duo board. Because the Duo is a 3.3 volt system, and NEOpixels absolutely need 5 volts, some sort of level shifting needs to be provided for the data line. A simple transistor with a couple of resistors could be used, or a commercial level shifter. Personally, I prefer a 74HC14 TTL Schmidt trigger inverter. It readily accepts the 3 volt signal from the Duo and outputs 5 volts if its VCC is connected to the 5 volt rail. The hysteresis of the Schmidt trigger also helps in any necessary signal cleanup, which experienced NEOpixel users will appreciate. Got all that? Sweet. Now let's move on to the wiring. Connect the ground line of the NEOpixel strip to the corresponding pin on the MilkV Duo. It is not recommended to connect the 5 volt line to that of the MilkV. You should use an external power supply to prevent damage to the Duo, although I had no problems connecting a 15 LED strip directly to the Duo's 5 volts, keeping the brightness of the LEDs down. I connected the MOSI pin 10, of the Duo to pin 1 of a 74HC14 chip. Pins 2 and 3 of the chip are connected together, and pin 4 needs to be connected to the NEOpixel's data line. Okay, now let's get into the code. I have source code to operate a NEOpixel strip from a Duo booting from a 1.0.9 bootloader SD card in the files section of the blog. It is broken into 3 files. Basically, duoneo.c contains the initialization code for wiring X, as well as the 2 arrays used. The strip array contains the initial color assigned to each pixel of your strip. These colors are converted to what I call NEOpixels and placed into the NP array by the convert function contained in the anims.c file. I have provided the infrastructure needed to start producing animations for your strips. I use the concept of segments, which allows us to have multiple animations on the same strip. These are defined in the segs array. I included one animation called Bop, which just sequentially bops a signal color from beginning to end of a segment. Once you've gotten this far, we are off to the races. An animation just manipulates the colors in the segments and then calls the convert function to send all of the segments to our strip. A micro sleep system call provides a delay before we repeat the whole process. So, happy NEOpixels! Please like and subscribe if you found this video useful, entertaining, or informative. Thanks for watching!